Hi, algebra students. We are starting a new section today. This is the section on relations and functions. So you have a warm-up today that you'll be doing in your journal. So I'm going to go ahead and share the PowerPoint that goes with today's lesson. Let's try that again. Share the screen. Okay, it looks like maybe it's shared. Maybe not. There we go. All right, so first thing it says to do is turn to page 58 in your journal and to complete maintaining mathematical proficiency problems 1 to 4, 6 and 7 on page 58. So go ahead and pause the video, try those problems, and then check back. Okay, welcome back. So you should have hopefully graphed those points. Those are all ordered pairs. You can graph them in the coordinate plane. On question number 1, the point -3, 1 should have been 3 units to the left, 1 up. And when it says describe the location, that would be in quadrant 2. So let's talk about the quadrants here for a minute. Let's go with pen. So if I have X and Y axis, this is X, this is Y. It's divided into 4 quadrants that we designate with Roman numerals. So 1, 2, 3, and 4, and we go in a counterclockwise manner. This is quadrant 1. Both X and Y coordinates are positive in this quadrant. So on that question number 1, -3, 1 would have been 3 to the left, 1 up, which puts you in quadrant 2. Question number 2, the point 2, 2 would be in quadrant 1. Question 3, the point 1, 0 would be on the x-axis. And question number 4, the point 5, 2 would be 5 to the right, 2 up, also in quadrant 1. On questions 6 and 7, you're asked to evaluate the expression for the given value of x. That means you take whatever number it is, plug it in for x, and see what you get. So on number 6, you should have had 2 times 3 is 6, plus 1 more is 7. And on number 7, it was 16 minus 4 times -4, which turns into 16 plus 4, which is 32. All right, let's look at our next slide. All right, so we are going to be discussing relations and functions. You have some vocabulary terms to write down on page 61 in your journal. Relation, function, and then you'll see a note section on that page. And if you could, in the notes section, draw these pictures and write what they are. So draw a mapping diagram, a set of ordered pairs, a graph, a couple of graphs. Actually, this one has a curved line going through it. This is just some separate points. Make an input-output table, make an equation. They don't have to have these exact numbers, but just go ahead and put those in the notes section. So go ahead and copy these down into the vocab on page 61, and again, add these ways to represent a relation into your notes on that page at the bottom of page 61. All right, let's look at some more vocabulary. You have a definition for domain and range, independent variable and dependent variable. Now you guys might have seen these before in pre-algebra last year. All right, domain is your set of input. Range is what you get out after you put something in for x. So that makes x the independent variable, and it makes y the dependent variable, because y depends on what you put in for x. So go ahead and stop the video and copy these vocabulary terms into your journal on page 61 as well. All right, next we have something called the vertical line test. This is found on page 62. It's one of the core concepts. So the vertical line test says if any vertical line, remember vertical straight up and down, if any vertical line passes through more than one point of a graph, the relation is not a function. So we have all those different ways to represent relations. That can be a table, it can be a graph, it can be a set of ordered pairs, it can be a mapping diagram. And then to tell whether a relation is a function, we can use the vertical line test. So one of the things you're looking for whenever you're trying to determine whether something is a function is to decide whether the x values repeat. If x's repeat, the relation is not a function. And we'll look at some examples of that. There's also a space on page 62 to add this expression to your notes. You're going to be seeing a lot of function notation in this unit. Function notation, you're going to see things written. Let me grab my pen here a minute. You're going to see this notation. All right, what this represents is f of x, or y is a function of x. All right, it doesn't mean multiplication. This isn't f times x. This is function notation. All right, a lot of times you'll see things written as y equals f of x. And all that means is y is a function of x. So you're going to be seeing this year, and then in all your other math classes, you're going to see this function notation. And all this means, it indicates the outputs of a relation. So again, x is what you put in, y is what you get out. So f of x is what you get out after you put your x values in. Let's look at some examples. These are on page 63, some extra practice problems. It says on exercises 1 and 2, determine whether the relation is a function, explain. All right, so remember I mentioned earlier, and I better get a different color because red's not going to show up on there. So let's try that again. Let's go with, let's go with blue. All right, so remember, one of the things we're looking for to decide whether or not a relation is a function is we're going to look and see if any of our x values repeat. All right, so notice we do have some y values repeating, but that doesn't matter. What matters is whether or not our x values repeat. So since I have -2 here and -2 here, this is not a function. It's a relation, it's a set of ordered pairs or a table, but it is not a function. So again, remember we talked about earlier the vertical line test. It said if a vertical line passed through more than one point, the relation, wasn't a function. So let's just look at these two cases. I have the point -2, 4, which is 2 units to the left and 4 up. This point over here is the point -2, 5, so that's 2 units to the left and 5 up. And since I can draw a vertical line that passes through those 2 points, it is not a function. All right? So here's a set of ordered pairs. Again, we're trying to decide if it's a function. So the thing you want to look at is are the x values. So I have 0, 1, 2, and 3. Since none of those x values repeat, this is a function. All right, so both of these examples are relations. This one is not a function. The second one is a function. All right, question number 3, we're trying to determine whether or not the graph represents a function. So in this case, we have a graph, so we're clearly using the vertical line test. So you're trying to see, can I draw a vertical line through this graph and hit more than one point? So I could draw one here, I hit 1 point. Draw one here, I hit 1 point. But when I get to 2, I can draw a vertical line that passes through 2 points. So it is not a function. All right, a lot of times you're going to be seeing graphs like number 4, where it's a curve and there are infinitely many points along here. It's not separate points like example 3. There are infinitely many points, but it doesn't matter where I draw a vertical line. I'm only going to hit 1 point on a graph. So this is a function. All right. Number 5, same idea. It says, oh, this time it says, find the domain and range of the function represented by the graph. So again, the domain are your x values and the range are the y values. So for our domain, and I'm going to use it as set notation. So you use these little braces. So I look at my first X value. So this is 0, right? There's a point here. This is the 0.04. So one of my X values in the domain is 0. I'm going to keep moving along. This would be 1. This point here would have an X coordinate of 2. Looks like I have one at 3, 4, and 5. So that's my domain. My range is the Y values that I have from these coordinates. So this is the point 0, 4. So I know 4 is in my range. This is the point 1, 4. So 4 is in my range, but I've already listed it, so I don't have to do it again. 2, 4. Again, I have the point 4. This point here would be the point 3, 4, or excuse me, 3, 3. We haven't had a Y value of 3 yet, so I'm going to list that. Then I have 4, 3. Oh, I already have 3. And I have 5, 3. Again, that's it. So my domain is the number 0, 1, 2, 3, 4, and 5, but my range is just the numbers 4 and 3. And you would also see this written. Usually we try to write them in numerical order if at all possible. And so we would write this as 3, 4. Again, you don't need to repeat things. So I didn't have to write 4, 4, 4, 3, 3, 3. Those are represented with the set notation right here. All right, on number 6, it's a little trickier because we don't have separate points here. There are infinitely many points on this V shape here. So let's talk about what our domain could be. So our domain could be, we know it's X values. So I know it has something to do with X. The biggest X value I have is all the way over here. My largest X value would be this coordinate of this point, which is 3. So it looks like X is less than or equal to 3 on the right. On the left side, the smallest X value, the furthest this graph goes to the left on the X-axis, is -3. So my domain is all numbers between -3 and 3. Right. My range, again, is the Y values. So I'm going to look at the graph and find the smallest Y value. So the Y's looks like right here. So if I look on the Y-axis, that's 0. So I know the Y's are greater than or equal to 0. And the highest this graph goes, the biggest Y value is, looks like, again, 3. Right, so the Y values go between 0 and 3, right? This biggest point here is the point 3, 3. So that's a Y value of 3. This is the point -3, 3. So again, the greatest Y value is 3. The smallest Y value is right here at the point 0, 0. Right, number 7 says the function y equals 12x represents the number y of pages of text a computer printer can print in X minutes. Identify the independent and dependent variables. So if you remember, we talked about that the independent variable is your X value. So the independent variable in this case is the X value, but let's talk about what the X value represents. So the independent would be minutes. And the dependent variable is the pages of text, or yeah, pages of text. Okay. On part B, it says if the domain is 1, 2, 3, and 4, what's the range? So we're using this problem here. So there are several different ways we can set this up, whatever you guys like to use. I find that a table works well. So that's my equation. I'm given the domain. So remember, these are my X values. So I have 1, 2, 3, and 4. My y values, my range, depends on what do I put in there, all right? So I put in 1 for x, which means my y value when x is 1 is 12 times 1, which would be 12. My y value when x is 2 would be 12 times 2, which is 24. My y value when x is 3 would be 12 times 3, or 36. And my y value when x is 4 would be 12 times 4, or 48. Okay, so again, domain 1, 2, 3, 4. The range is 12, 24, 36, and 48. So this is your range. All right, today's assignment is 3.1 on page 108 in your book. You're going to do problems 3 to 21 odd. The link to these pages is found in today's agenda. It also includes the textbook pages if you want to read through some more examples. So good luck, and if you have any questions, just send me an email.